Let's calculate this integral from minus infinity to plus infinity of sine squared of omega 1 x divided by 2 times e to the minus j, where j is the imaginary unit, times omega. Omega is not the same as omega 1, times x, and then we divide by pi omega 1 x squared divided by 2 dx. This integral can be rewritten as integral from minus infinity to plus infinity of sine squared omega 1 x over 2. Instead of e to the minus j omega x, I can simply replace cosine omega x here, because we see that sine squared of omega 1 x over 2 is an even quantity, and also the denominator, because we have x squared. And since we integrate from minus infinity to plus infinity, we just have to take the real part of this, because if we consider the imaginary part and we integrate, that will go to 0, because the overall function inside the integral, that is the integrand, is an odd function, whereas in this case it is even function. So we can only consider the real part of that. Then we divide by pi omega 1 x squared over 2 dx. So these two integrals are equal. This can be written as 1 over pi omega 1, and then I have integral from minus infinity to plus infinity. Then sine squared can be written like this. In general, I can use the formula sine squared alpha equal to 1 minus cosine alpha divided by 2. So I will use this formula here. Therefore, I can rewrite this as cosine omega x minus cosine omega 1 x times cosine omega x, all divided by x squared dx. And now, the first integral I will just rewrite like that, but I will split the integral into 3 parts, not just 2, because the cosine of omega 1 x times the cosine of omega x can be rewritten like this. So in this case, I'm going to use the formula cosine alpha times cosine beta is equal to the cosine of alpha plus beta over 2 plus the cosine of alpha minus beta over 2. Therefore, this can be written like this: 1 over pi omega 1 integral from minus infinity to plus infinity of cosine omega x over x squared minus cosine of omega 1 plus omega times x divided by 2x squared minus cosine of omega 1 minus omega times x divided by 2x squared dx. Or if you want, I can also rewrite this as omega minus omega 1, because the cosine is an even function, so I can change the sign of the argument. And now I can integrate by parts, like this. So if I integrate by parts, I can rewrite this as 1 over pi omega 1 integral from minus infinity to plus infinity 1 over x. So when I integrate by parts, I'm going to integrate the 1 over x squared in all of the 3 terms here. And here I have omega 1 plus omega times the sine of omega plus omega 1 times x divided by 2 plus omega minus omega 1 times the sine of omega minus omega 1 x divided by 2 minus omega times the sine of omega x dx. And finally, now this is where I can use some complex calculus, because it is easier to integrate these three integrals, because in this case we have three terms inside the integral, and the three terms have the same form because we have an integral from minus infinity to plus infinity of something like a constant time sine of alpha x over x dx, and this is an integral that we have already computed. It is much easier than the one we started from. So when I integrate this function here, I get the signum function of alpha multiplied by pi. And remember that the signum function is just alpha over the absolute value of alpha, or if you want, just the absolute value of alpha over alpha. That's just the same. Therefore, here we get that this is equal to 1 over omega 1 times omega plus omega 1 over 2 signum of omega plus omega 1 plus omega minus omega 1 signum omega minus omega 1 over 2 minus omega signum omega. This is equal to 1 over 2 omega 1 times absolute value of omega plus omega 1 plus absolute value of omega minus omega 1 minus absolute value of omega. This is how I can rewrite the result. Remember that this is equal to the integral from minus infinity to plus infinity of sine squared omega 1 x over 2 e to the minus j omega x divided by pi omega 1 x squared over 2 dx. Now take a look. If we set omega equal to 0, this complex exponential will be equal to 1 if omega is equal to 0. And in here, this will yield 2 absolute value of omega 1. And if omega 1 is positive, so also if omega 1 is positive, we get that this function is equal to 1. The integral of that function is equal to 1. And indeed, in that case, this would be a probability density.